Okay, we got a wedge under this angled thing here, and I want to figure out how much force I need to place on that to get it to move if I'm applying 400 newtons up at the top of that handle there. Okay, so with that, I think I'll start with the wedge on this one. Okay, and I'll draw my wedge just like that. Okay, I've got my applied force P here, and then I'm going to have friction acting back against it both on the top and the bottom. I'll call this one F, and I'll call the top one FC, okay? Which means I also have an NC given right there, and what I'll call N right there. So that's what I've got going on my wedge. Now I'll take the handle, which is kind of a rigid body, which I'll do like that, okay? I have my, and I know this force, so I'll just put the number in there right now. This is 400 newtons. Okay, I've got a pin, BX, BY. And then I've got the normal force and friction force going on at C. So the normal force, equal and opposite, will be like that, and the friction force will be the same like that. And again, it's the same force, just in opposite directions. Okay, so let's start with the wedge. We will draw or we'll write our equilibrium equations. I'm not going to have a moment equation on this one. Wedges, again, they don't rotate, they just slide. Okay, so I don't have any moments that I have to worry about in this one. I definitely have a P like that. I have an F in that direction. I also have an FC cosine of that angle, which is 15, like so. And then I have got the corresponding NC normal force, which is sine of 15 equals 0. I do the same thing with my Y direction. I'm going to have N straight up. I'll have the NC cosine 15 down. Okay, my friction is going to be positive. It's up just a little bit, which will be FC sine of 15 equals 0. Okay, so at this point, I've got 1, 2, 3, 4, 5 unknowns. Okay, 2 equations, that's not enough. However, I've got friction occurring at 2 spots. This is a wedge. For that to occur, my friction's got to slip both places, right? So I know that F equals 0.3 N, and I know FC has to equal 0.3 N. For motion to occur, slipping has to occur. They're at their maximum, or mu s n. Now, I still don't have enough equations, but what I can do is I can go over to my angle there, okay? Recognizing I don't really care what's going on at B, so I'm just going to sum the moments about B on this guy, okay? And give myself a 5th equation to solve all of these answers here. So I've got that 400. It's 450 up. It's a positive moment, so I just go 450 times 400. And then I've got NC and FC occurring now. They each have a horizontal and a vertical component. This gets a little tedious. I'll let you kind of go through and check it on your own if you don't believe me, but I'm going to take the horizontal distance 300 times the vertical component of FC, or I'm sorry, NC, which is cosine of 15. Okay, then I'll do the vertical distance, which is 20, times the horizontal component of NC, which is going to be sine of 15. Okay, I have to do the same thing for the friction, FC. So I'll take the horizontal distance, 300, times its vertical, which is going to be the sine. I'm going to take 0.3 times NC, right, because I know FC is 0.3 now. We've already talked about that, so I'll throw that in there right now. Okay, and then I'll take the vertical distance times the horizontal, which will be the cosine. Okay, and again, I threw in the fact that I know the friction force is 0.3 times N, so I did that kind of right away. Here's the deal. That big ugly equation there only has one unknown in it. Okay, and from that I can find that NC equals 689. So from that big equation, again, knowing what the friction equals related to the normal force, I can find that normal force to be 689. Okay. I can take that, plug it into that Fy equation, and find that N is going to be equal to 612. Now that I've got N and NC, I can go up to that top equation and I can find that P is 561 newtons. Okay. So again, with the wedge, break it up into pieces, treat it like a machine. Okay. And then recognize that the friction force for that thing to start moving, everything's at that maximum friction force. That's the smallest amount that's needed to get motion to start. And that's what we apply in there. Okay. You can have a whole series of equations that you can solve for the unknowns that you're looking for.